In this video, we're going to be looking at finding linear equations. We'll look at some ideas about linear equations, some features of linear equations, and then we'll be using those features to graph linear, or excuse me, to find the actual equation itself. So linear equations in two variables are equations with two variables. Usually those variables are x and y, and both x and y are raised to the first power. Also, to have a linear equation in two variables, I can't rewrite it in such a way that x and y are multiplied by each other. So if we have two variables, both raised to the first power, not multiplied times each other, then we're good to go. We have a linear equation in two variables. We've seen that graphs of linear equations in two variables form straight lines in the rectangular coordinate system. And in fact, we've seen these two lines before, y equals 3x minus 4 and y equals negative 1x plus 2. Let's go ahead and graph those two lines. Here is the graph of y equals 3x minus 4, here in red. We've seen that before. We get a straight line, and every point on that line is a solution to this equation. With y equals negative x plus 2, we get a different line. Here it's the blue one, and every point on this line is a solution to that equation. In particular, two interesting points are the x-intercept, where the line crosses the x-axis, and the y-intercept, where the line crosses the y-axis. In y equals negative 1x plus 2, the x-intercept is at 2, 0, and the y-intercept is at 0, 2. For y equals 3x minus 4, the x-intercept is at 1.3 repeating, comma 0, and the y-intercept is at 0, negative 4. So we've seen those two lines in previous videos. Now, a couple of special forms of lines are horizontal and vertical lines. Horizontal lines are of the form y equals a, where a is some real number, and vertical lines are of the form x equals a, where a is some real number. Most of the lines that we deal with will be skewed or oblique, like the two lines we saw in example 1. And when you write a line which is skewed or oblique, you'll see both variables. That is, you'll see both x and y. In the horizontal lines, you'll just say y equals a number, and in the vertical lines, you'll see x equals a number. Let me go ahead and graph a couple of horizontal and vertical lines. So I've graphed the line y equals 2. Y equals 2 goes through 0, 2. It clearly does not go through the, doesn't pass through the x-axis, so there's no x-intercept there. But there is a y-intercept at 0, 2. The other thing about this line is what you'll notice is y equals 2 is horizontal because every point has y value 2. That's what we're saying there by y equals 2. X can be any value you want, but the y values all have to be 2. So regardless of what the x value is, the y value is 2, and that ends up as a horizontal line. That works for any other number. If we did y equals negative 5, then all y values would be negative 5. A similar thing happens when I have x equal to a number. Let's say I have x equals 3. Then all x values are 3. And the y values can be any numbers that I want. So that gives us this vertical line with all x values of 3. So that's the idea behind these horizontal and vertical lines. Obviously, x equals 3 is a vertical line, y equals 2 was a horizontal line. As said earlier, most of the lines we'll deal with are going to be oblique or skewed. They won't be straight vertical or straight horizontal. Um, and so in most of the other lines that we'll deal with, we'll see the variable x and the variable y. And there's two kind of forms that we use a lot. There's other forms as well, but there's two forms that we use a lot in this class. One of which is called the standard form of a line. That's where the line is written as a times x plus b times y is equal to c, where a, b, and c are all real numbers. And generally speaking, A and B usually aren't 0. If they are, then we're back in the horizontal or vertical line. So the standard form of a line is AX plus BY equals C. The other form of a line is called the slope-intercept form of a line. It is y equals m times x plus b, where m and b are both real numbers. Now, both of these have their advantages and disadvantages. Obviously, in example 1, we had the slope-intercept form of a line for both of our lines. We had y equals 3x minus 4 and y equals negative 1x plus 2. So slope-intercept is really nice for graphing. Standard form of a line is nice for other things as well, doing certain algebraic things. But both are very common forms of lines that you'll see. And again, there are other forms of lines. These are the two that we focus on. So let's take a look at a line that is in slope-intercept form, and we'll graph it and examine what's going on with this line. In particular, we'll see what happens as x values are increased by 1. Now, we've already graphed this, so we see our standard graph. And what I'm saying is, if we start at a point on this line, let's start at 0, 4, and then we increase the x value by 1, we end up at the point 1, negative 1. So notice that as I increase the x value by 1, the corresponding y value change was an increase of 3. So we went an increase of x by 1, and then the y value increased by 3. If I do that again, if I go from point 1, negative 1 to the point 2, 2, you'll notice that once again, moving over 1 in the x direction made me move up 3 in the y direction. And every single time we do that, I move over 1 in the x direction, I would move up 3 in the y direction. Over 1, up 3. So for every change of 1 unit in the x direction, we've changed 3 units in the y direction. Now, another way to look at this is saying, what if I went over 2 units in the x direction? If I went over 2 units, then I would have went up by 6. So the change in y would have been 6 if the change in x is 2. If I would have went over just a third, I would have went up by 1. So over by a third, up by 1. This is the concept of slope. How much you go over in the x direction versus how much you go up in the y direction. And in this case, and in all cases, slope is going to be represented by a ratio. And that ratio is going to be change in y over change in x. And if I was saying every time we move x 1 unit to the right, the y value went up by 3. And then I also said, well, if we change x by 2 units, then the y value moves up by 6. And I also said if we change x by 1/3 of a unit, then the y value movement is 1. All of those ratios are the exact same number. In this case, 3. So the slope of a line is change in y over change in x, and you can actually track that using any 2 points on the line. Notice that that ratio happens to be the exact coefficient of the x when the line is in slope-intercept form. That is why it's called slope-intercept form, because the coefficient of the x is going to be the slope of the line. The other part of that form is that if you plug in 0 in for x, the y value has to be -4 in this case. And that gives you the y-intercept. So the y-intercept is 0, comma, this -4. So that's why we get slope-intercept form of the line. Slope-intercept form has m as the slope, and the y-intercept is 0, b. Let's look at another line, y equals 1/2 times x plus 3. And let's examine this graphically. In particular, we'll see what happens as the x values are increased by 1 unit. So I've graphed that. Notice that y equals 1/2 x plus 3 has a y-intercept of 0, comma 3. So that's what that 3 comes out to be. The coefficient of x is 1/2. And if you examine what happens going from, let's say going from the y-intercept, I would go over 1 unit in the x direction, and in the y direction, I'd went up by 1/2 of a unit. So I went over 1 in the x direction, the y increase would be 0.5. And if we did that again, we'd move over 1 again, the y increase would be 0.5. Over 1, increase of 0.5. If we wanted to, we could also say that a fraction of 1/2 means I go over 2 in the x direction and up 1 in the y direction. Over 2 in the x direction, up 1 in the y direction. Or if we wanted a different ratio, you could see we move over 4 units, up 2. And you could go backwards as well. You could go left 2 units and down 1. That would be a -2 in the x direction and a -1 in the y direction. All of those ratios are going to be the same number, which is 1/2. So in this case, the slope again, if I think of it as change in x over change in y, change in y divided by change in x, the change of y was 1/2 when x moved over 1. The change in y was 1 when x moved over 2. The change in y was 2 when x moved over 4. And the change in y was down 1 when x moved left 2. So negative 1/2. All of those fractions are 1/2 or 0.5 as a decimal. So once again, slope is the coefficient of this x when a line is in that slope-intercept form. And we saw that the 3 indicated where our y-intercept was. Now, the nice thing about slope is that it's independent of the 2 points I pick. All of those ratios of change in y over change in x were the same no matter what 2 points I was dealing with. So the slope of a line can be determined by any 2 points on that line. All we have to do is find the change in the y values between the points and divide by the change in the x values between the points. Now, generally we call x1, y1 0.1 and x2, y2 0.2. This is the y value of 0.2. This is the x value of 0.2, the y value of 0.1, the x value of 0.1. That's what the subscripts mean. And if I'm looking at the change in y values, it's just going to be the y value of 0.2 minus the y value of 0.1. The change in x values is going to be the x value of 0.2 minus the x value of 0.1. And if we have a line, this fraction, this ratio will be the same no matter what 2 points I pick, as long as they're not the same point. So we can find slope of a line by given 2 points on that line, if we're given 2 points on that line. And we do so by this slope formula. M, which is the letter we use for slope, is equal to y2 minus y1 divided by the quantity x2 minus x1. Now, as far as horizontal and vertical lines go, they have special slopes. The slope of a horizontal line is 0. You can see that if we have a horizontal line, then the y values will be the same. So we get y2 minus y1, if they're the same, will be 0 over some number. 0 over any number is 0. So a horizontal line will have slope 0. On the other hand, in a vertical line, if we have 2 points, then the x values will be the same. And then we're dividing by 0, which means that the slope will be undefined. So the slope of a horizontal line is 0, and the slope of a vertical line will be undefined. Sometimes people will state that a vertical line has infinite slope rather than slope being undefined. You can use either term you want. Let's go ahead and do some calculations for slope. Let's find the slope of a line between 2 given points. Our first pair of points is 3, 2, and 9, 4. If you want to push pause on the video and try this on your own, go ahead and try this on your own. So here are the 2 points. I'll call 3, 2.1 and 9, 4.2. So slope, which again, oftentimes is written just as the letter M, is change in y over change in x. And when we do that calculation, it's going to be the y value of 0.2 minus the y value of 0.1 divided by the x value of 0.2 minus the x value of 0.1. So the y value of 0.2 is the number 4. The y value of 0.1 is the number 2. So the numerator of that ratio is going to be 4 minus 2. The denominator is going to be the x value of 0.2, which is 9, minus the x value of 0.1, which is 3. When I simplify that, I'm going to get 2 over 6, which is 1/3. So the slope of a line through those 2 points is going to be 1/3. And that's it. That's all we're asked to do. Let's do another example. Let's find the slope of a line between these 2 points. The first point is -1, -2. The second point is 3, -10. Go ahead and push pause on the video and try this example. In a couple of seconds, I'll show you how it's done. All right, so I'll do this one. Slope, change in y over change in x, that's y2 minus y1 over x2 minus x1. In this case, I got some negatives. So be careful when you plug in negatives. Usually when I have negatives, I plug those in inside of parentheses. The y value of 0.2 is -10. The y value of 0.1 is -2. The x value of 0.2 is 3. The x value of 0.1 is -1. Now, when I do that calculation, -10 plus 2 is going to be -8. And 3 minus -1, that's like 3 plus 1, is going to be 4. -8 over 4, simplified, is -2. So the slope of this line would be -2. That is the slope of the line between these 2 points. Notice that it's perfectly fine to have a negative slope, perfectly fine to have a positive slope like we had earlier, perfectly fine for our slope to be in a fraction form. It's all right for our slope to be a whole number or an integer as well. So in example 5 and example 4, we found slope using the slope formula. That's the y2 minus y1 over x2 minus x1. But with an equation of a line, I can also find the slope by writing a line in slope-intercept form. If I have a line in slope-intercept form, I can essentially just read off the slope and read off the y-intercept. If a line is not in slope-intercept form, for instance, if the line is in standard form, then I can still find the slope and the y-intercept by rewriting it in slope-intercept form. Let's take a look at example 6 and do just that. This first line, this first equation, is already in slope-intercept form. The second equation is in standard form. So I'll find the slope and the y-intercept for both of these lines. If you want to do this on your own, push pause on the video. In a couple of seconds, I'll show you how this is done. Okay, so this first one is already in slope-intercept form. And if we know slope-intercept form is y equals m times x plus b, then we can just say the slope is the coefficient of x. We already have that form. Here, the coefficient is an implied 1, so there's an implied 1. Now, some people call the y-intercept just this numerical value of -5, but technically, we should say that the y-intercept is the point at which we cross the y-axis. And if I plug in 0 for x, I'll get a y value of -5. So 0, -5 is that point, which is the y-intercept. So when I have slope-intercept form, I can basically just read off the slope and read off the y-intercept. If I don't have slope-intercept form, then I can force slope-intercept form by isolating y, that is, getting y by itself on one side of the equation. And this is exactly akin to just solving an equation for y. I would subtract x from both sides. That would give me 2y is equal to -x plus 6. And then I would divide both sides by 2. Now, when I divide the left-hand side by 2, I get 2y over 2, which is going to give me y. When I divide the right-hand side by 2, I have to divide each term by 2. I'll take -x over 2, and then I'll take a plus 6 over 2. So I have to divide by both terms. Usually I do that in my head, but for right now, I'll just write the step. -x over 2 can be written as -1/2 times x, and then 6 over 2 is a positive 3. So this is y equals -1/2 x plus 3. That means my slope is -1/2, and my y-intercept is 0, 3. So once I get y equals mx plus b, I can read off the slope and read off the y-intercept very efficiently. Go ahead and try example 7 on your own. Push pause on the video and see if you can come up with the slope and the y-intercept of these two lines. In a couple of seconds, I'll show you how these are done. All right, x equals 4 is a vertical line. Excuse me. That means it's straight up and down. If you think about the slope formula, you could take any 2 points like 4, 0 and 4, 2. And we've mentioned this before, but the change in x value is going to be 4 minus 4 in the denominator. We'll get different change in y values in the numerator. Let's say I take 4, 0 and 4, 2. We'd have 2 is the second y value, 0 is the first y value. You'd get something like 2 divided by 0, which is undefined. So since every vertical line is going to have that form, the slope here is going to be undefined. Now also, in terms of the y-intercept, since x equals 4 is a vertical line, it's actually not going to pass through other vertical lines, like the y-axis. So the y-intercept does not exist. Sometimes in short for does not exist in math, we'll put DNE. So does not exist is written as just DNE. That's just shorthand for does not exist. So there's no y-intercept. The y-intercept does not exist, and the slope is undefined. Another way you could say that the y-intercept does not exist is that the y-intercept happens when the x value is 0. If you plugged in an x value of 0 there into the equation, you'd get a false statement. It would say 0 equals 4. So we know that you cannot plug in an x value of 0 to get a true statement. Now, that is a horizontal line. These skewed lines or oblique lines are a little bit more straightforward. In this case, we have 3x minus y equals 5. What I would start to do is I'd put this line in slope-intercept form. That would mean I'd subtract 3x from both sides. If I subtract 3x from the left-hand side, I just get negative y. If I subtract 3x on the right-hand side, I get minus 3x plus 5. And then I would divide everything by a negative 1, because that's the coefficient of y. If I divide the left-hand side by negative 1, I get y. If I divide the right-hand side by negative 1, that gives me a positive 3x and a minus 5. I know I'm not showing that step, but that's what it is. Now we have slope-intercept form. We have an equation that looks like y equals mx plus b. So I know that the slope is going to be the coefficient of the x now, which is 3. And the y-intercept is going to be the point 0, negative 5. So that's how we can find slopes and y-intercepts on any given line where they exist. And we know that for vertical lines, slope is undefined, and on most vertical lines, the y-intercept doesn't exist. There is one weird case where x equals 0 is the y-intercept, so every point, y-axis is x equals 0, and so technically every point on the y-axis intersects the y-axis. But most lines, we get a nice real number slope, a nice y-intercept. Now we are ready to start creating lines. So let's say we want to find a linear equation given some of the features of a line. We just saw that if we have an equation that looks like y equals mx plus b, then we can find the slope and find the y-intercept very easily. But that works in reverse as well. If I have the slope and if I have the y-intercept, then I can immediately write down the equation of the line. I can write down y equals mx plus b. So as long as I can find the slope and the y-intercept of the line, this b value in particular, then I can find the equation of any line. And so that's what we do. If we're trying to create a line, then we always start by looking for the slope first. Once I found the slope, then I'll find the b value, which we know is the y value of the y-intercept. After I have the slope and the y-intercept, then I can simply write y equals mx plus b, with the specific m and the specific b that I just found. Now, finding this b value is going to be very consistent. We'll do that the same way almost every time. Finding the slope is a little bit different. There's multiple different ways to find the slope. We just saw a slope formula earlier. We could have also been given a slope. And we can also find slopes using parallel and perpendicular lines. We'll see that in some examples later on. So let's start with an example. Let's find the equation of the line whose slope is -1/2 and that goes through the point 6, -8. I'll go ahead and do this one immediately. So here we go. I know I want to find something that looks like y equals mx plus b. So I need to find the m and I need to find the b. Well, in this case, the slope is given to me as -1/2. So I'm done. That's all I have to do to find the m. I'm done with finding the m, that is. Now, if I know the m is -1/2, then I know the line is going to look like y equals -1/2 times x plus b. Now, the other feature I know is that this line goes through the point 6, -8. That means when I plug in 6 into x and -8 into y, I get a true statement. So all I have to do is plug in that point, specifically the point 6, -8, into the equation that I have. And I know that that's going to be a true statement because that's what it means for a point to be on the line, is that when I plug it in, I get a true statement. So if I plug in -8 for y and 6 for x, I get -8 is equal to -1/2 multiplied times 6 and then plus b. This is an equation in one variable. So I can solve that by doing standard algebra. We get -8 is equal to -3 plus b, and then I would add 3 to both sides. So adding 3 to both sides gives me -5 is equal to b. So this means that my equation has slope of -1/2 and b value of -5. So the equation that I get is y equals -1/2 times x minus 5 or plus -5, either way. And you can check that that's true either by graphing or by algebra, by plugging in this point, 6, -8, getting a true statement and seeing that it has slope of -1/2. So you can graph that and see the slope and see that it goes through 6, -8, or you could just look at it and see the slope and plug in 6, -8 and see that it gives you a true statement. But that's the equation, and then that's the final answer. In this case, the slope was given to me, and we knew it went through a point. There's going to be various ways to find the slope, but to find the b, after I've found the slope, is going to be the same process every time. I'm going to plug in some point I know into the equation and then solve for b. Here's another example. This says find the equation of a line whose slope is 4 and that goes through the point 2, 1. Go ahead and push pause on the video and try this on your own if you'd like. In a couple of seconds, I will show you how this is done. Now, I oftentimes just write y equals mx plus b right up top so I know what I'm dealing with. I know what I'm trying to find. In this case, once again, the slope is given to me as 4. So I know my equation is going to look like y equals 4x plus some value of b. And then I can just say plug in the point to 1 into that equation. When I do that, be careful that you plug in the 2 into the x spot and the 1 into the y spot because every ordered pair is x comma y. But plug in 1 into y and 2 into x, and then I can solve for b. In this case, I get 1 is equal to 8 plus b. And if I subtract 8 from both sides, I get that b has to be -7. And therefore, my final answer is that the equation I was looking for is y equals 4x minus 7, or sometimes people would say 4x plus a -7. And that's it. That's the entire process. One more thing, if you are writing the equation of a line, make sure you have the y equal to part. Some people, when they write it, they'll just write 4x minus 7. 4x minus 7 is not the equation of a line, it's just an expression. Y equals 4x minus 7 is the equation of the line. So make sure you write the y equals part as well. So now we know how to find the equation of a line when I'm given the slope and I'm given a point that the line goes through. Now, there is a special case with vertical and horizontal lines that we should cover while we're looking at this. Let's say we want to find the equation of a horizontal line, which goes through the point 5, -9. Now, you can do this in a couple of different ways, but the way I like to do it is say, since it's a horizontal line, it's going to have the special form that looks like y is equal to a number. And therefore, since we have the special form of y equal to a number, we know that our line is going to look like that. And in particular, what number does it equal to? Well, it's going to have to equal the y value of that point, which in this case is -9. So y equals -9 is the horizontal line that goes through the point 5, -9. In a similar way, if it said find the vertical line that goes through 5, -9, we would know that the vertical line that goes through that point would have x equals a number. And in this case, it'd have to be x equals 5 because that's the x value of that point. So horizontal lines, vertical lines, again, horizontal lines are all y equals a number. Vertical lines are x equals a number. Those are kind of the unique scenarios. Most of the scenarios are going to be the oblique or skewed lines. So let's focus on that. Let's focus on other types of lines that are not horizontal and not vertical. In this case, it asks us to find the equation of a line that travels through points -1, -2, and 3, -10. Those points should look familiar. We found the slope of a line through those 2 points earlier in a previous example. So we would start off by, first off, knowing that I want to create a line. I'm going to use the slope-intercept form. You could use a standard form, but it's a longer process. You could also use another form like the point slope form, which again is something we're not going to cover here. So what I would do is I would start by saying we want to find the slope between these 2 points. We actually already did that in a previous example. Here's that work that we did earlier. Remember, it's the y value of 0.2 minus the y value of 0.1. That's -10 minus -2, all divided by the x value of 0.2 minus the x value of 0.1, and that would be 3 minus -1. We got -8/4, which is a -2 as the slope. Once we have the slope, then everything works the exact same as our previous examples. We say now we know the line is going to look like y equals -2x plus some b. And now I can plug in a point. I'm going to just put another little space there. And so now I can plug in a point. Doesn't matter which point I plug in. I can either plug in -1, -2, or I can plug in 3, -10. I think I'll plug in 3, -10, but if you wanted to plug in -1, -2, you'll see that that leads to the same value for B. So the y value is -10, the x value is 3, I get -10 is equal to -6 plus b. So b has to be -4 when I add 6 to both sides. Now I have the slope of -2 and the b value of -4, and I can say with confidence that my equation is y equals -2x minus 4. So that's the equation for the line that goes through the point -1, -2, and that goes through the point 3, -10. You can check that that's true by plugging in those 2 points algebraically. You can also check that that's true by graphing this line using some sort of technology and seeing that it goes through both of those points. So I've graphed that y equals -2x minus 4, and I can see that it goes through -1, -2 right there. And then if I look at 3, -10, sure enough, it goes through 3, -10 as well. So again, I can find that that works algebraically, or I can just graph and see that the line goes through the 2 points that I want it to. Let's do another example. This says find the equation of the line that travels through the points -3, -1, and -4, -1. Try this on your own. Push pause on this video, try it on your own, And then in a couple of seconds, I'll show you how it's done. So the first thing we do is write y equals mx plus b. The second thing I do is always find the slope. I always want to find that slope. That's like the first thing that I actually compute. And it's always the y value of zero point 0.2, which in this case is a positive one, minus the y value of 0.1, which in this case is a negative one, divided by the x value of zero point 0.2, which is a negative 4, minus the x value of 0.1, which is a negative 3. In this case, when I do that, I end up with a positive 2 in the numerator, negative 4 minus negative 3, that's like negative 4 plus 3. That's a negative 1 in the denominator. And I'll usually simplify that when I can. In this case, I can. The simplified version is negative 2. So now I know my equation is y equals negative 2x plus b. Excuse me. Now I can plug in either of those 2 points. And if you plugged in negative 3, negative 1, that's perfectly fine. If you plugged in negative 4, 1, that's perfectly fine. You'll get the same b value regardless of which point you plug in, as long as you've done the math correctly. I'll plug in 0.2, but if you plugged in that first point, you'll be just fine. And in fact, it's kind of a nice thing to do both every once in a while. I'll plug in negative 4, 1. So 1 goes in for the y value. Negative 4 goes in for the x value. That means 1 is equal to 8 plus b. And so b is negative 7. Subtract 8 from both sides, and I get b as negative 7. Now I have the slope and the b value, and now I know my equation. My equation is y equals negative 2x minus 7. And if you're ever in doubt, you can always plug these 2 points in, see that you get the correct values, and, or I should say, you can graph this using some technology and see that it goes through those 2 points. Now, obviously, in the 2 previous examples, I just gave random points out. Sometimes you can be given an x-intercept or a y-intercept, which are really nice points to use, because in the x-intercept, the y value is 0, and then the y-intercept, the x value is 0. That's what happens in example 13. It says, find the equation of a line that passes through the point 4, 6 and has x-intercept of negative 4, 0. Or sometimes people would say the x value of the x-intercept is negative 4. There's nothing really interesting here that's different than the previous 2. It's just giving you an x-intercept instead of giving you some other point. So go ahead and push pause on the video and try this one on your own. In a couple of seconds, I'll show you how this one is done. So like I said, traveling through this point and this point, we use the exact same features as we did last time. First feature we use is the slope formula, the y value of 0.2 is 0, minus the y value of 0.1 is 6, divided by the x value of 0.2, which is -4, minus the x value of 0.1, which is a +4. That gives me a -6 over a -8. Which negative over negative gives me a positive. 6 over 8 reduces to 3/4. And so I get a slope of 3/4. Now, again, some books may say x-intercept of -4 because they will use just the value rather than the point. I tend to say that the x-intercept is the point. So it's the point where we cross the x-axis. Other times, other books may say it's the value of the point when you cross the x-axis. But there we go. So now we're ready to set this up. We have y equals 3/4 times x plus b. I can plug in the x-intercept or the 0.46. I think I'll plug in the x-intercept this time. So I'll plug in the point -4, 0. 0 is always nice to have. I should say not always, but most of the time zeros are nice to deal with compared to other numbers, because when you multiply by 0, you get a 0. When you add something to 0, you get that something back. So 0 is going to be equal to -3 plus b. Adding 3 to both sides gives me b has to be 3. So now I know that the equation of the line that I was looking for is y equals 3/4 times x plus 3. And again, if you're looking for confirmation that you have the right equation, then either plug in these points and see that you get true statements, or graph it and see that it goes through those 2 points. In this case, both cases are both ways you do this, you'll confirm that we do have the right equation. Now, being given a slope and finding a slope through 2 points are really nice ways of finding slopes of lines. The two other ways in this section where we're going to find slopes of lines are when I compare my line to a line that is parallel to it, or a line that is perpendicular to it. If I know my line is parallel to another line, then I know that my line has that same slope as the other line does. In other words, if we have 2 lines that are parallel, then their slopes have to be the same. So if the first line has slope a over b, then the second line has slope a over b. On the other hand, we may have perpendicular lines. Perpendicular lines are lines that intersect at a right angle. So they intersect and they look like a T, or they look like a grid. If 2 lines are perpendicular, then they have slopes which are negative reciprocals. That means if the first line has slope a over b, then the second line will have slope negative b over a. So I've flip-flopped the numerator and denominator, and I've put a negative out front. If I know my line, the one I'm trying to find, is parallel to another, then I can find the slope of that other line and use that as the slope of my line. If I know my line is perpendicular to another line, then what I can do is I can find the slope of the other line and say my line has to have slope which is the negative reciprocal of that other line. Let's do an example. Here we have example 14, which says find the equation of the line that is parallel to y equals 2x minus 7 and travels through the point 1, comma 6. Now, the first thing we need to point out is that y equals 2x minus 7, that's the given line, has slope of 2. I want to create a line. I want y equals mx plus b, and I want my line to be parallel to this one. And therefore, I want my line also to have slope of 2. Parallel lines have the same slope. Now I know my equation is going to be looking like y equals 2x plus b, and I'm in the same place I was in the previous few examples. I just plug in the point that I know my line goes through, plug in the point 1, 6, and solve for b. In this case, we'd get 6 is equal to 2 times 1 plus b, or 6 is equal to 2 plus b, and so b is equal to 4. And then we're done. Now I know the equation I was looking for, the equation of the line that was described in the problem is y is equal to 2x plus 4. That's the line that's parallel to y equals 2x minus 7 and goes through the point 1, 6. That's y equals 2x plus 4. By the way, if you graph these, both y equals 2x minus 7 and y equals 2x plus 4, you can see that they're parallel because they're moving in the same direction. And obviously, because they're parallel and moving in the same direction, they never cross. If you scroll out, you can see parallel lines, since they have the same slope, are moving in the same direction. So that's a good visual that we have the correct line. And obviously, you can see points that it goes through, like 0.16. Let's do another example. Here it says, find the equation of a line that is perpendicular to y equals negative 3/4 x plus 9 and travels through the point 8, 1. So we'll go ahead and do that. Before we get too far into this, I want to point out that the slope of the given line, this line is in slope-intercept form, so the slope of the given line is negative 3/4. I want to find a line that's y equals mx plus b that is parallel, or not parallel, perpendicular to this one. So I want my line to have slope, which is the negative reciprocal of negative 3/4. So for 3/4, we take the reciprocal, which is 4/3, and then we negate that negative 4/3. If you take a negative of a negative 4/3, we get a positive 4/3. So the negative reciprocal of negative 3 over 4 is a positive 4 over 3. That is going to be the slope of the line I'm trying to find. Y equals 4/3 times x plus b is going to be the equation. And then I can plug in a point. In this case, the only point that I'm given is the 0.81. So I have to plug in that 0.81. When I plug in 1 for y and 8 for x, we're going to end up with kind of an ugly numerical value as my b, a fraction value, not terribly ugly, but just a fraction value. 8 times 4 is 32. So I get 1 is equal to 32 over 3 plus b. And then I would subtract that 32 over 3 from both sides. And I would get negative 29 over 3 as my b. Now that is the improper fraction. If you wanted to write that as a mixed number, it'd be negative 9 2/3. So negative 9 2/3 or negative 29 over 3, either way is perfectly fine. The equation that I have there is going to be y is equal to positive 4/3 times x minus 29 over 3. Again, if you want to confirm that you got this correct, you can either plug in the 0.81 and then see that my slope is the negative reciprocal of the given slope, or you could graph both this equation and this one and see that they do look perpendicular and that this one goes through the 0.81. I have graphed both lines. The purple line was the given line and the black line was the one we just found. You can see that they do cross, and where they cross, we get these nice 90-degree angles. We get nice right angles where these cross. And you can also scroll in and see that you do in fact go through the 0.81. So the line we found goes through the 0.81 and appears to be perpendicular to the given line. Let's do one more example. Let's find the equation of the line that is perpendicular to y equals 5x minus 1 and travels through the point 3, 8. Go ahead and push pause on the video and try this on your own if you want. And then after that, in a couple of seconds, I will show you how this problem is done. All right, so let's go ahead and do this. We have y equals 5x minus 1. That's already in slope-intercept form, so I can easily see that the slope of the given line is 5. I want my line to be perpendicular, so I want the negative reciprocal of 5. Oftentimes, when you have a integer number, it's easier to take that number that's an integer and write it over 1. So the slope is 5, but I'll think of it as 5 over 1. If I want to find a perpendicular slope, it's going to be the negative reciprocal. So I flip 5 and 1 upside down. I change the role of the numerator and denominator, and then I negate the number. In this case, I'm going to go from slope of 5 to slope of negative 1/5. So my line needs to look like y equals negative 1/5 times x plus b. And then we plug in that point. In this case, the point that I'm given is the point 3, 8. When I plug that in, we plug in an 8 for the y value. We'll plug in a 3 for the x value. Once again, I'm going to be dealing with fractions. That's perfectly all right. We get 8 is equal to negative 3/5 plus b. Adding 3/5 to both sides, I either get 8 3/5 or 8.6 or 43/5. Doesn't matter which way I write this at this point, but obviously if there's a question arise and it asks you to write it in a certain way, then write it in that certain way. If it asks you to write it as an improper fraction, then we're writing 43/5. If it's asking for your answer as a mixed number, then it's 8 3/5. If it asks for a decimal, then it's 8.6. So whichever way things ask us to write it, write the answer, we will write the answer that way. So my equation is going to be y is equal to negative 1/5 times x plus 43/5. Or if I wanted to use decimal versions, it'd be y is equal to negative 0.2 times x plus 8.6. Both of those are the same equations, just written in different ways. Negative 1/5 is the same thing as negative 0.2. 43/5 is the same as 8.6. So that's how we find equations of lines if we're given a line perpendicular to the one we're looking for and that goes through a point. Notice that in every single line that we found, the first thing we did was find the slope of our line. Then the next thing is we found a b value. That's always by plugging in a point. And then we simply wrote the equation as y equals mx plus b. Again, there's a lot of different ways to find slopes. Sometimes it was given to us. Sometimes we found it using the slope formula. Sometimes we found it by being given a parallel line. Sometimes we found it by being given a perpendicular line. So that ends our video on creating lines.